Hello, welcome to another section of Maths. Let's look at this question. Differentiate 7 raised to the power 2x plus 10 divided by 2 ln 7. Differentiate 7 raised to the power 2x plus 10 divided by 2 ln 7. Now, you remember in my previous video, we integrated this problem, and at the end of the day we had this whole thing as what answer to that question, which was this. And you remember I said that to confirm that this answer is correct, or to find out whether the answer we had to this integral of this one was correct, I'll be differentiating that answer which we had to this one, which is what the whole of what this one. Okay, so in this video I'm going to differentiate this one using substitution. And if you're able to get this one back, it means that the answer that we had to integral of 7 raised to the power 2x plus 10 dx, which gave us answer of what this one is correct. And also remember that I said that anytime you differentiate something, the answer that you get to that something, when you differentiate that particular answer, it should give you what that something back. Okay, so here this is our something, we integrated it and we had this, so we are going to differentiate this answer to see if you can get the something back, which is what this one. Okay, so without wasting much time, let's get into the video. First, let's write our solution. What are we working on? This one. Okay, that is what we are going to differentiate. So let's bring it down here. Please don't get confused with differentiate and then this symbol. Instead of writing this one, I chose to do it this way. This one is the same thing as that. Okay, now before we continue, remember I said we are using substitution. Okay, so what we are going to do here is that we are going to set y be equal to this one. We are going to set y be equal to this one. Why? Because with the substitution approach, we have to form equation before we can use the substitution approach to solve this one. This substitution that I'm going to use is not like it's just like when you are using the quotient rule, the substitution that you make. This one is not like that. It doesn't work like that. Okay, no, you can use quotient rule to solve this problem, or you can also use natural log approach to solve this problem. But if when you want to use quotient rule, there is no need for you to form an equation before what solving it. But if you want to use logarithm, or maybe let's say natural log, or the substitution approach that I'm going to show or demonstrate in this video, you have to form an equation before that approach will work out for you. Okay, good. So let's set y be equal to this. Okay, so now let's write our equation. Y is equal to 7 raised to the power 2x plus 10 divided by 2 ln 7. Here, though it's an equation, but we want to make it what? A linear equation. We want to make it what? In a linear form. Okay, so we are just going to change this one to a linear form of what? Equation. So this is what we are going to do. We are going to multiply through by the denominator, which is 2l and 7. 2l and 7. You multiply this one by this, and you multiply the whole of this thing by also what? This. Okay. Okay, so let's multiply through. Okay, so when you multiply through by 2l and 7, on the right hand side here, you could see that this and this are the same. So this and this will cancel out and to be left with what? 7 raised to the power 2x plus 10. And when you come to this side, this is going to give us 2l and 7 times 10, and to give us 2l and 7y. 2l and 7y. So 2l and 7y is equal to 7 raised to the power 2x plus 10. Now you see, now is what we wanted it to look like. That is the linear what equation. So here I think we can do our substitution from here. Somebody may choose to differentiate this problem directly from here. That one is for those who are very good with algebra. They are very good when it comes to mathematics. No matter how hard the algebra involved in that particular question is, they will be able to manipulate it. But like I said earlier on, I always want everything to be simple for you guys. Okay, so here I'm going to do substitution. Yeah, I'm going to do substitution. I'm going to let u be equal to 2x plus 10. 2x plus 10. 2x plus 10. Now here, let's differentiate. Now when you differentiate this, you are going to get du, and when you differentiate 2x plus 10, you are going to get 2 dx. And it's so because when you differentiate this one, is constant. When you differentiate constant, the answer to it is 0. Now when you differentiate this, the power of x is 1. So multiply that one by 2, give you 2. Decrease the power by 1. 1 minus 1 is 0. Any variable, any number at all raised to the power 0 is what? 0. Raised to the power 0 is what? 1. Raised to the power 0 is what? 1. So when you differentiate this, you are going to get du is equal to 2 ds. 2 dx. Okay, we will not find dx here. We will not find dx here. We are going to leave it as it is, because when we replace this one with u and then we differentiate this one, we will get du here, of which we can replace it with what? 2 dx. So we are going to leave this one as it is. Now that we know what is going to replace 2x plus 10, let's put it there and then differentiate. Two ln 7y is equal to 7 raised to the power u. 2 ln 7y is equal to 2 raised to the power is equal to 7 raised to the power u. Here we are going to differentiate. Now when you differentiate this, you can use the product rule. Yeah, of course, when you look at it, you say, oh, this one, you have to use the product rule. Yeah, of course. But this one is constant. So when you use the product, you get the same answer as that. But if you like, just don't bother yourself using the product rule at all. Just do it as the way I'm going to solve this one. Now this one is constant, so what we are going to do is to differentiate this y, and when you differentiate it, you are going to get dy, and you multiply it by this. So when you differentiate this, you are going to get 2 ln 7 dy. Okay, now let's use the product rule to find out if you get the same thing. Now using the product rule, first maintain this, let's say maintain this y and differentiate this. When you differentiate constant is 0. 0 by multiplied by y is what? 0. Okay. Then let's put that 0 there. The next one is maintain this one and differentiate y. When you differentiate, we are going to get what? Dy. 2l and 7 multiplied by dy will give us what? Dy. So 0 plus 2l and 7 dy will give us what? 2l and 7 dy. You see, that is why I told you don't bother yourself using the product rule. Anytime you got to differentiate something of this nature, just put the constant aside, focus on the variable, differentiate it, whatever you get, multiply it by the constant and put down your answer. Okay, now here 7 raised to the power u here is not all that easy as compared to this one. It involve a series of steps to differentiate this. But in this video, although I always want to show you every step in getting my answer or in getting my answer to each question that I solve, but here I'm not going to show you every step. I only write the answer for derivative of 7 raised to the power u because I have already done a video on how to differentiate questions of this nature or problems of this nature, like 7 raised to the power x, 10 raised to the power x, 7 raised to the power u, 8 raised to the power t, something of that nature, how to differentiate them. I've already done a video on how to solve or how to differentiate problems of that nature. So what I will do is I will leave a link to that video in the description section below. So if you want to find out how, the answer to this one is going to be arrived, then you go click on that link and then you watch or you enjoy yourself with it. Okay, good. So now when you differentiate 7 raised to the power u, what you are going to get is 7 raised to the power u multiplied by l and 7. 7 raised to the power u multiplied by l and 7. And as I said, if you want to find out how I got the answer for this one, you just go and click on the link that I will leave in the description section below, and you see you'll be able to solve problems of what this nature, and you'll be able to also know why I had that particular answer. Okay, so we are going to differentiate as I said, and we have already differentiated, so let's write down our answer. Good. So when you differentiate this, that is what you are going to get, and that is what you are going to get. That is 7u multiplied by l and 7 du. L and 7 du. L and 7 du. Now let's put back the value of u. Let's put back the value of u. What we substituted u for. We replace 2 raised to the power 2x plus 10 with what? U. Now that we are done with the differentiation, we should let's probably put it back. Let's put it back because we are done with the differentiation, and anytime you move from one world to another to solve your problem, when you are done, probably you have to go back. Okay, so let's put x back into our equation and then let's end it. Okay, so 7 raised to the power u, we know that u is equal to 2x plus 10, and we also know that du is equal to 2 dx. So this is the reason why I said in the other part that there's no need finding ds, or we shouldn't bother finding what ds, but rather we should leave it as it is. This is was the reason why I said that, because here we are just going to put ds back. We know the value for du, that is du is equal to 2 dx. So wherever we see du after differentiating, that is what we are going to put it there, that is 2 dx. So we will replace du with this one, and also u with what, this. Okay, so let's replace them. Okay, good. Okay, here when you multiply what is in the bracket, you're going to get 2 ln 7 dx, 2 ln 7 dx, 2 ln 7 dx. Now when you multiply what is in the bracket, I said we are going to get 2 ln 7 dx, and it's the same thing here. 2 ln 7 into bracket 7 raised to the power 2x plus 10 dx. Now I did it this way because of the cancellation that is going we are going to include in this section. Okay, so that our presentation will look nice, that is why I did this way. So don't just get confused when you want to open the bracket, or maybe if you don't want to bring the bracket, just forget it. You can omit the bracket and write it as 2 ln 7 times, or 2 ln 7 dot 7 raised to the power 2x plus 10 dx. You can write it as that, or you can write it as 2 ln 7 7 raised to the power 2x plus 10 ds. Anyhow you write it, it will be accepted, provided it is what, multiplying, it will be accepted. But as a student, you have to know how to present your work to make it look what, nice. Some teachers do award some marks for very hot, nice presentation. So always let your work be hot, presentable. Okay, that's how I did it this way. So here 2 ln 7 dy is equal to 2 ln 7 into bracket 7 raised to the power 2x plus 10 bracket close dx. Well, are we done? Though we are done with the differentiation, but this part is like an algebra part. We have to, compute some values, eliminate some, maintain some, and then isolate some. Okay, so here our motive here is to isolate dy over dx. In any differentiation that you do, at the end of the day, we should see something like dy over dx, dt over dp, d blah blah over d blah blah. So here the variables involved were y and then x. So our d blah blah will be what, dy and then what, dx. Okay, so it's going to be dy over what, dx. But how are we going to get that from here? So all that we are going to do is that, looking at this left hand side, 2 ln 7 is attached to this. In order to get this one out, we have to what, divide this one by 2 ln 7, or multiply this side by 1 over 2 ln 7. When you come here to get this dx out, we have to either divide the whole of this thing by dx, or multiply this side by 1 over dx. And when we do that, it makes the equation unbalanced, because with equation, both left and right hand side has to be the same. Whatever you do to the left hand side has to also be what, done in the right hand side also. So to go by this, we are going to multiply through by 1 over 2 ln 7 dx, 1 over 2 ln 7 dx. When you do that, you could see that here, when you multiply this side by 1 over 2 ln 7 dx, you could see that this ln 7 will cancel with that ln 7 that we are multiplying through, and it will be left with dx here. And when you come to this side, you could see that dx will be eliminated and this one also will be eliminated to be left with what? This. So let's multiply through by 1 over 2l and 7 dx. Okay. When we multiply this equation by 1 over 2l and 7 dx, that is what we are going to get at the end of the day, and the same thing as divide both sides by 2l and 7 dx. So don't just get confused, they are all the same. Here when we factor this one, or when we bring this one here, you could see what the fraction, that is 1 over 2l and 7 dx. Okay, so now that we have multiplied both sides by 2l and 7 dx, now let's see how this is going to help us get our dy over ds. Now let's first look at the left hand side, right hand side. 2l and 7 dy divided by 2l and 7 dy. You could see that this and this are the same, so this and this will cancel out and to be left with dy over dx. Now let's come to the right hand side. dx is here and also another one is here, so this and that will cancel out, and also we are having 2l and 7 here. At the same time we have another one here, so this and this will also cancel out and to be left with what? 1. So 1 multiplied by 7 raised to the power 2x plus 10 will give us what? The same thing, will give us 7 raised to the power 2x plus 10. So dy over dx is equal to 7 raised to the power 2x plus 10. Hey, cool! We've gotten what we integrated the other time. That is 7 raised to the power 2x plus 10. That is what we integrated. You remember? You see, I told you that differentiation and integration, they move together. If you differentiate one, if you differentiate something and get an answer for that something, when you integrate that answer you had to that something, it should give you back your something. Okay, it's like the Lambert W function. When you're having something like let's say x multiplied by raised to the power x, if you want to get your x back, you just plug it into the Lambert W function and that one will give you your x back. Okay, so here if you integrate something and you want your question back, all that you are going to do is not to use the Lambert W function approach. All that you are going to do is to differentiate the answer you had and it will give you your something back. Okay, so our something in that integral was what? 7 raised to the power 2x plus 10, and we had 7, this one divided by 2l and 7, and we said that, oh, we have to get our something back. And what is that something? This. So what should we do? Then we differentiate, and at the end of the day we have gotten it back. That is 7 raised to the power dy over dx equals to 7 raised to the power 2x plus 10. Okay, so let's end it. Therefore the derivative of this one is equal to 7 raised to the power 2x plus 10. 7 raised to the power 2x plus 10. Please, we are done with the differentiation, but if you have any question, kindly leave it in the comment section below and I'll do my possible best to answer you. Okay, but don't hesitate if you have any question at all. You just feel free and then ask any question. Where you are having any question where you don't understand, you let me know and I'll take my time to walk you through, or I'll take my time to answer you. Okay, all right, that's it. Please, if you like this video, kindly give it a thumbs up, subscribe and comment. Thanks for watching.